This is problem number 5 from section 8.2. It says airports A and B are 475 kilometers apart on an east-west line. Let's go ahead and draw that real quick. That would be A, B, 475 kilometers apart. East-west line. So east-west. Jim flies in a northeast direction from A to airport C. So he drives east-west, or what is it? Northeast direction. Northeast direction. So northeast direction to some airport C. All right? So this is airport C. And then from C, flies 310 kilometers on a bearing of 125 degrees, 20 minutes to B. So he flies from C to B, and we know that that is 310 kilometers. Now, the hard part about the problem is the bearing part. So remember, a bearing goes from due north. So the angle they're telling us is this angle from due north. And that's 125 degrees, 20 minutes. Which we know we can figure that out by saying 125 degrees plus 20 minutes over 60 minutes, which is 125.3333 repeating. So we know that this angle here from the basically a due north to this spot where he was flying is 125.33 degrees. Now, what does that tell us? Well, we know that this would be due east. So if I take 125.33 and I subtract out 90, so I subtract out 90, that's going to give me 35.333. So that angle right here, just from the east direction to where he was flying, this is 35.33. Well, I know that opposite interior angles, if this angle from due east is 35.33, then this angle in here is the exact same, 35.33. So that's the hard part of the problem, is just going through and taking the 125 degrees, 20 minutes from when they use the word bearing, so from the north, due north axis, and subtracting out the 90 to get this little angle from due east, and then knowing that that is a complementary angle to this angle that's between, or this angle B, that's between our two distances. So we label this A, this B, and the C. And in the problem, they say, how far is C from A? So they really want you to know, what's this right there? Well, that's little side B. This is little side C. And this is little side A. So they give us A, they give us C, they want us to find B. Let's take a look at our law of cosine versions here. Well, our law of cosine versions, we want to find B. We probably want to use B squared equals A squared plus C squared, because they give us A, they give us C, minus 2AC cosine B. So let's go ahead and use that form. I'm just going to put it in the upper right here. In fact, I'll just cover that up a little bit. That's okay. And we'll say that B squared equals A, which is 310 squared, plus C, which is 475 squared, minus 2 times 310 times 475, A and C, and that's cosine of 35.33. So then I can say that B equals the root, if I take the root of each side, 310 squared plus 475 squared minus 2 times 310 times 475 times cosine 35.33 repeating. I'll use 4 decimal places. So B equals, let's plug that in the calculator. Now, I already have the 35.33 in the calculator from doing the subtraction of, from doing 125 minus 90. So I'm just going to leave that there because then I'll use that version when I do this whole cosine 35.33. So let's piece it together. 310 squared plus 475 squared minus 2 times, I better put this in parentheses, so 2 times 310 times 475 times cosine, and this time I'll grab that 35 number, put it in there, and that's what's inside the radical. So then I do the root of that. Answer tells me that A and C airports are 285 point, round to the nearest kilometer, so it's 0.4, so it's 285 kilometers apart. So this distance here from A to C was 285 kilometers.